After a single-use package has done its job, there are three possible outcomes: litter, trash, or recycling. While all waste stream items are facing similar issues, this video will discuss only plastic packaging for the sake of brevity. First, let's have a quick review. Plastics are called polymers. The building blocks of polymers are monomers. The chasing arrow symbols refer to the monomers. Think of the general heading as the genus, with many species as subsets which have specific properties for specific applications. For example, the polypropylene resin made for an injection molded lid will not work to make all the other things which you see here, which are also polypropylene. We should probably be talking about downcycling instead of recycling, reason being that recycled plastic is to a large extent a wild card. Add too much and the product fails or does not have essential cosmetic appeal. Now, I tried to develop an infographic to capture the possible outcomes, got no further than this. Hope it helps. A Pareto analysis shows that most plastic is discarded as waste. Consumers all over our future plastic planet opt for litter or trash by an overwhelming majority. The consensus is 91% of plastic is not recycled. So what can be done to change consumer behavior about litter, for starters? Well, shaming campaigns have been largely ineffective. For decades, Texans have been admonished not to mess with Texas, but a lot of them still do. The only thing that seems to be working is beverage container deposits. Unfortunately, there is no political will to mandate deposits at a federal level. An alternative to evil fossil fuels is biodegradable plastic made from plants. Great idea. So why hasn't it caught on? Well, there's two factors: timing and cost. If the plastic packaging breaks down before the end of the service life, it's a mess. You have to throw out a whole batch of product. Now, giant food companies are not really keen on bioplastics because it will make their raw material costs skyrocket. If bioplastics derived from agricultural sources catch on in volume, the price is going to go up. It's inevitable. Now, there's a burgeoning worldwide movement to punish the plastic industrial complex via what is extended producer responsibility, or EPR for short. The virtue signaling logic is to make the plastic industrial complex pay for trashing the environment and killing wildlife. While it has been effective for many things, it has not been enacted for packaging due to the prohibitive cost which must be passed along to the consumer. A major tenet of EPR is take-back. This is supposed to induce the manufacturer to design for recyclability. It really doesn't matter if King Consumer opts for the litter or landfill. Now, there is some good news here. The recycling rates for PET #1 have gone up. They're now up to about 33%. Now, that means that 2 out of 3 water and soda bottles are not recycled. Whether 1 out of 3 ain't bad is a judgment call. Waste to energy is another way to deal with litter and landfill plastic. The broad strokes are: the refined polymer contains a lot of potential energy. Burning creates energy which can be converted to electricity. You burn responsibly with scrubbers, of course. Now, this is caught on in Europe mainly because of lack of landfill space. It's estimated that only about 12% of plastic waste has been incinerated. The jury is out about waste to energy as a viable business model. Fulcrum Energy is the most prominent U.S. waste to energy outfit, and they don't disclose earnings. The city of Harrisburg, Pennsylvania's foray into waste energy resulted in bankruptcy. Now let's look at the 9% which does get recycled. Now, not all plastics are created equally recyclable. Some are more recyclable than others. Besides consumer behavior, there are 2 reasons the rate of recycling is so low. economic sustainability, contamination, and regulation. Whether obtained from the landfill or recycling stream, the used plastic is the raw material for the recycler. It's not complicated. The recycler has to bundle or grind the plastic to sell it to a plastic processor. If the raw material cost is X and it costs 3 times X to bundle it or grind it and get it to the landfill, it's obviously not a viable business model. The key to recyclability is purity. The plastic must be segregated with other products made from the same building blocks, same monomers. The recycler's product is most valuable if it is free from cross-contamination. Here's an example. If a bundle of number 1 PET bottles, which weighs several hundred pounds, is contaminated with 1 bottle of PVC, you have to throw the whole thing out. It's worthless to the processor, and you can only take it to the landfill. Now, you may have heard that China used to be a dumping ground for plastic scrap, but no more. If the plastic waste is not literally over 98% pure, they will not accept it. The so-called sword fiat has put many scrap dealers out of business. Number 7 is the least valuable of all. By definition, it is a catch-all item for a mashup of different polymers in one package. Stand-up pouches are touted as environmentally friendly because they take up less space in the landfill. They are virtually worthless to the recycling stream. Here's why. A typical pouch has a polyester outer layer, ink, adhesive, polyethylene sealant layer, and a different kind of polyethylene for the zipper. If there's no market for used pouches, the options are either pay to take it to the landfill or burn it in waste to energy. Now you see why recyclers gladly pay a premium for pre-sorted waste. In Scandinavia, there are up to 20 different recycling bins. Regulations and common sense about food and medical are also factors. Nobody in their right mind wants their packaged food or medical devices made from plastic collected at curbside. At this juncture, the only polymer FDA approved for prolonged and direct food contact is number 1 PET. Unfortunately, even if the consumer conscientiously sorts in all these bins, as they do in Scandinavia, and the recycler segregates the polymers, there is no market for some of them. Unfortunately, number 3 PVC and number 6 are the least recyclable. There's just too much variation in the species. 2018 was the year plastic bashing reached a tipping point. In response, many CEOs pledged ambitious goals for recycling content in about 6 years. It remains to be seen whether these goals will be attained. Most likely, it will not matter for 2 reasons. The public doesn't have a memory, and the CEOs, for the most part, will have moved on. Now, there is an opportunity here. Remember, plastic is comprised of strings of monomers. If you can figure out how to extract the monomers from the plastic, you will be the lowest cost producer by far. You would obviate the need for using fossil fuels, and you would remove an awful lot of plastic from the planet.